All right, welcome. Let's work number one from the AP Calculus 2023 free response. Okay, and this is for A, B, and BC. And this is the one with the customer at the gas station pumping gasoline into a tank. All right, so part A is saying, using correct units, interpret the meaning of this integral in the context of the problem. Okay, so I'm going to need some paper here, and let's think about it. Okay, what does the function that we're integrating represent? It's probably a rate, right? The rate of flow of gasoline. So the integral of the rate is going to give us the total amount of gasoline. So I'm going to say it's going to be the amount of gas in gallons per second multiplied by seconds. If we're integrating, then we multiply the units. In gallons pumped into the tank between t equals 60 and t equals 135 seconds. Okay, making sure that we've got the units of the independent variable and the units of the dependent variable. Okay, and use a right Riemann sum with the three subintervals 60 to 90, 90 to 120, and 120 to 135 to approximate the value. All right, so right Riemann sum, width, height, represented by the right edge, right? So it's 0.15. Plus 90 to 120. Okay, that's a width of 30 as well. Multiplied by the height, which is represented by the right endpoint, that'll be 0.1. And then the last one is 120 to 135. That's a width of 15, represented by its right endpoint. That's 0.05. Okay, and that's going to be my Riemann sum, and I'm going to stop there. I'm not going to simplify, unless I need it in a later part. Okay, so that was part A. Must there exist a value of C between 60 and 120 such that f prime of C equals 0? Okay, so they're asking about the mean value theorem. Must there be a place where the derivative equals this value? So I'm going to say, well, let's just check on the average rate of change of f between 60 and 120. So f of 120 minus f of 60 over 120 minus 60. Okay, we'll go back to the table, and it's 0.1 minus 0.1 in the numerator, so that's equal to 0. And f is differentiable. They said it in the statement of the question. So my conclusion is yes, there must be a point like that. So f prime of C equals 0 for some C between 60 and 120. Okay, part C. The rate of the flow of gasoline in gallons per second can also be modeled by this g of t function. Using this model, find the average rate of flow. Okay, so rate is g, average rate will be the average value of g. So we're going to say, all right, average rate of flow is going to be 1 over 150 minus 0, average value integral, 0 to 150 of g of t dt. And, you know, I'm going to use the calculator for this because we don't know how to anti-differentiate that. We don't want to do that at all. What we're going to want to do, we don't need to, oh no, we are going to take the derivative. So I'm going to store this into y1 right now. Because if I'm going to use it more than once, then I think it's worth storing. So I'm going to go to y1, and I'm going to say, all right, t divided by 500 multiplied by cosine of, maybe I should use a fraction bar for here, t over 120, and then I square that. And then, yeah, just like it looks. Okay, so I've got that in there. And now, if I'm running this integral, I'm going to ask for maybe a fraction, 1 over 150 times the integral from 0 to 150 of y1. I think for a while, and I get 0.959, so 0.96 to round to 3 decimals. What I was going to point out is that we need to make sure we're in radian mode because this function did involve trig, and if you were in degree mode, you're going to get a different number, and that would be wrong. Okay. Which, you know, if you did realize you were in degree mode. That's actually not the end of the world, because I think you only get penalized once. I've graded a problem like this before in the summer, but I forget what the rules are. I think you lose the answer point once, but then we have the degree mode answers sitting there like ready to use in that event, and then you don't keep getting penalized. All right, 1D is going to be find the value of G prime of 140. Okay, so G prime of 140 is going to equal, I'm just going to take the derivative by hand, or not by hand, with the calculator. The derivative of y1 at 140 is going to be negative 0.0. Okay. And it said, interpret your meaning in the context of the problem. And it didn't say using correct units, but I think it might be good for us to write down the units so that we're like pointed in the right direction for the meaning. So I'm going to go over here and I'm going to say, all right, gallons per second is G, T is seconds, so the derivative of G is going to be gallons per second per second. Okay, so this represents the rate of change of whatever G represents. So we're going to go and we're just going to grab that. And we go back to the definition of G. It said the rate of flow of gasoline. So it represents the rate of change of the rate of flow of gasoline at T equals 140 seconds. Okay, and that's number one.